Hi friends, welcome to Shraddha Tutorials. Today we are going to solve first problem from fourth exercise from the chapter Real Numbers of class 10. Okay, what exactly the question here is? We have to find whether the rational number means whether the given rational numbers gives a terminating or non-terminating decimals. Okay, how to find or how to know whether a rational number gives us a terminating or non-terminating decimal. Okay. It's very easy to find whether the given rational number gives you a terminating or non-terminating decimal. How? See, any rational number can be written in the form of p by q. If you do prime factorization to the denominator, the prime factorization should be in the form of 2 to the power of n or 5 to the power of m or 2 to the power of n into 5 to the power of m. Means if the denominator has prime factor only 2 or only 5, our denominator can be written in the form of a product of 2's and 5's, then surely the given rational number gives you a terminating decimal. If not, it gives you a non-terminating decimal. Denominator should have only 2's or only 5's or both combination of 2's and 5's. Okay, it should not have any other prime apart from 2 and 5. Okay, now let us imply same to the given numbers and check whether the rational number gives us terminating or non-terminating decimal. Now first one, that is 13 by 3125. Now we have to represent denominator in terms of product of prime factors. Okay, denominator can be written as 5 into 5 into 5 into 5 into 5, that is 13 by 5 to the power of 5. So now here we have shown that denominator in the form of 5 to the power of m. Okay, so as per our rule, so denominator should be either 2 to the power of n or 5 to the power of m or 2 to the power of n into 5 to the power of m. Okay, so here I am having 5 to the power of m. So since denominator is in the form of 5 to the power of m, this rational number gives you a terminating decimal. Okay, so since the denominator is in the form of 2 to the power of n into 5 to the power of m, the given rational number is a terminating decimal. Second one, 17 by 8. See, this is in the form of 2 to the power of n. So as we discussed, the denominator should be either 2 to the power of n form or 5 to the power of m or 2 to the power of n into 5 to the power of m. Okay, yes. So now this is in the form of 2 to the power of n. The denominator is in the form of 2 to the power of n. So this gives a terminating decimal. A terminating decimal. Okay. Now third one, that is 64 by 455. So we have to write 455 in terms of product of prime factors. So let me start with 3, no chance, 5 9's, 5 1's. Next prime number is 7 13 times. So this can be written as 5 into 7 into 13. Now see, this is not in the form of 2 to the power of n into 5 to the power of m. So this will not give you a terminating decimal. Okay, so you can write this as since denominator not in the form 2 to the power of n 5 to the power of m, 64 by 455 gives a non-terminating decimal, a non-terminating decimal. Now fourth one, that is 15 by 1600. So 1600 can be written as 2, 800 times 2, 400 times 2, 200 times 2, 100 times 2, 50 times 2, 25 times 5 times. So this can be written as 2 to the power of 1, 2, 3, 4, 5, 6 into 5 to the power of 2. Now see, denominator is in the form of 2 to the power of n into 5 to the power of m. So this rational number gives you a terminating decimal. Okay. Since denominator is in the form of 2 to the power of n into 5 to the power of m, given a rational number gives you a terminating decimal. Now fifth one, that is 29 by 343. See, the value of 7 cube is nothing but 343. So this can be written as 7 cube. So since the denominator is not in the form of 2 to the power of n into 5 to the power of m, this rational number will not give you a terminating decimal, it gives you a non-terminating decimal. Okay. Same reason here. Okay. Now sixth one, that is 23 by 2 to the power of 3, 5 to the power of 2. So as we discussed, the denominator is in the form of 2 to the power of n into 5 to the power of m, so that we can say easily that the given rational number gives us a terminating decimal. Okay. Now seventh problem, that is 129 by 2 to the power of 2, 5 to the power of 7, 7 to the power of 5. See here, it is not in the form of 2 to the power of n into 5 to the power of m. Even though it has 2 and 5, it includes 7 also. So according to our rule, denominator should be in the form of 2 to the power of n or 5 to the power of m or 2 to the power of n into 5 to the power of m. That is, denominator should have only 2 as the prime factors or 5 as a prime factor or 2 and 5 as prime factors. But here the denominator has even 7 also as one of the prime factor. So the given rational number will not give you a terminating decimal. This gives a non-terminating decimal since the denominator is not in the form of 2 to the power of n into 5 to the power of m. Now eighth one, that is 6 by 15. So this can be written as 3 into 5. So as we discussed, it should have only 2 or 5 or 2 and 5 as prime factors, but we have here 3. But here in this case, see, numerator can be written as 2 into 3 and denominator as 3 into 5. 3 will get cancelled and the final is 2 by 5. So it has only 5. The denominator is in the form of 5 to the power of m. So the given rational number gives a terminating decimal. Okay. So 6 by 15 gives a terminating decimal. Now ninth one, that is 35 by 50. See, this can be written as 35 by 2 into 5 into 5. Again, you may have doubts that if you expand this, maybe there is chance for cancellation. Of course, even if you do cancellations, you will be having either 2 or 5 or both, is it not? Apart from that, you don't have any other prime numbers as a factor. So that this rational number gives us a terminating decimal. Okay. Since the denominator is in the form of 2 to the power of n and 5 to the power of m, 35 by 50 gives us a terminating decimal. And now the last one, that is 77 by 210. So now we have to represent this in terms of product of prime factors. So 210, 2 105 times, 3 35 times, 5 into 7. So denominator can be written as 2 into 3 into 5 into 7. Again you may have doubt, most probably if you expand numerator you may get cancellation, means in the sense so apart from 2 and 5 any other number may get cancellation, but here you can write this as 7 into 11. So 7, only 7 will get cancelled, 3 will be here. So if 3 is here, then surely this rational number will not give you terminating decimal. Okay. So as per the rule, the denominator should be either 2 to the power of n or 5 to the power of m or 2 to the power of n into 5 to the power of m. Okay, na? So it's not following that rule. So this rational number will not give you a terminating decimal. Okay. So since the denominator is not in the form of 2 to the power of n into 5 to the power of m, the given rational number will give you a non-terminating decimal but not a terminating decimal. I hope you all understood the content what I have discussed in this video. Thank you for watching this video. Thank you very much.